Oh, sorry. Okay. It's again that. Oh, recording it. Oh, correct. Now see. So now tell me, what is the input for CLR? Yes. Yesterday we discussed, right? What is the compiling structure? So first, what we have to do? We have to convert source code to the mission code, right? Source code to the mission code. So what is the mission code here? Have you remember? So in Microsoft Intermediate Language, MSIL code is the binary code. Okay, MSIL code is the binary code. Okay, used for is generated by converting source code. Okay, with the help of C# compiler. C# compiler is converting source code into the MSIL code. Okay, that MSIL code is input for the CLR. The MSIL code is the input for the CLR. Check it this. Okay, source code. Okay, source code converted by the language compiler C# compiler into the MSIL code, Microsoft Intermediate Language. The MSIL code is converted into the converted to the bytecode with help of CLR. Bytecode with help of CLR. Got my point? Yes. Understand? Yes. Now what is the input for CLR? MSIL code is the input for CLR. Yes. Understand everyone? Please respond.
Yes.
Right. Now, CLR, Common Language Runtime. So remember this in any language. So source code is converted into the MSIL code, a byte code. Okay. In that case, nothing will happen. Okay. We don't allocate the memory or okay. We don't do anything. When we are converting the binary code or mission code, okay, or MSIL code or byte code, we can call different languages. Okay. That code is converted to the output code. When we are converting that okay MSIL code to the output code, when we are converting MSIL code to the output code, okay, that time we have to do the all the things, allocation of the memory. Okay, those all the things you can do at the time. Right now, see, okay, CLR architecture. Now I open the CLR architecture. Observe here clearly. Input loaders are used to load the MSIL file, Microsoft Intermediate Language file to the MSIL file to the CLR, Common Language Runtime. Input loaders are used to load MSIL file into the CLR, Common Language Runtime. Next, access specifiers are modifiers. Used to specify how the variables are accessing, how the methods are accessing, how the classes are accessing, how the variables are accessing, how the classes are accessing. So, for example, here we have mainly three modifiers. Okay, public, protect, okay, public, protected, and private. Public, protected, and private. If you use the private, it will access within the method or class. If you use the protected, it has to okay. The method of protected or class protected will be executing by the okay child class, and public will access throughout the project. Okay, right? Next. CAS, code access security. The security is provided by the okay code. For example, if I want to prepare a login page, for that what we require? Okay, we have to write the okay some code and we have to validate with the database whether the values are available in database or not. If the values are available in database, then I can go with the just I can redirect to the other page. If not, what happens? Show the error. That security is providing by the code actually. So code access security. Next, role based security. So we have different roles. For example, in an application, I have different modules like manager module, admin module, employee module. Like that, we have different modules we have. We have different modules. So when we are using uh, those modules, we have to provide the security. So manager can access all the employee pages as well as admin page also. Admin can access his page as well as the employee page. Employee can access only the employee page. That means we have different roles. So based on the roles, we are providing the security. Then we can call it a role-based security. Role-based security. Observe here, code-based security based on the code. So example I said, login page simply. Now code-based security, role-based security. Based on the roles, we are providing the security. Next, point number 3 here. Common language specification. Common language specification. So remember, as of now, we are discussing only C#.NET. But actually, so .NET framework supports more than 60 languages. .NET framework support more than 60 languages. In those, C#.NET, VB.NET, J#.NET, VC++.NET. So like that, we have 9 languages are developed by Microsoft. 9 languages are developed by Microsoft. Even C, C++ also supports Microsoft framework, but those are not developed by the Microsoft. Those are also we can use in the Those are also we can use in the Microsoft framework. But we are using, actually we are discussing only the C#.NET. So that's why when we are converting source code to the mission code, or we can call it the MSIL, Microsoft Intermediate Language. Source code to the mission code. So after conversion of the source code, we have to specify which language code it is. So when we are converting mission code to the output code, mission has to know. Mission has to know which language code it is. CLS, Common Language Specification, specifies which language code it is. Next, CTS, Common Type System. It is used for specifying which type of data types used. Like value data types or reference data types. Value types like int, float, double. Reference type like array, string, etc. Array, string, etc. Array, string, etc. Right? So this is about CAS, RBS, CLS, CTS. Next, memory management. Allocation and deallocation of the memory is called memory management. We have 2 types of memory management: static memory management and dynamic memory management. Remember this. Static means fixed. Remember this word. Static means fixed. Dynamic means Dynamic means runtime memory allocation. Runtime memory allocation. 1 minute. Right. Let's do memory allocation, static memory allocation, dynamic memory allocation. So memory allocation done at compile time is called static memory allocation. Memory allocation done at runtime is called dynamic memory allocation. So next, JIT compiler. Remember one more thing. So static memory allocation uses a stack memory, STAC stack memory. Dynamic memory allocation uses the heap memory. Heap memory means a temporary memory. Temporary memory. Clear? Right? Next, JIT compiler. Just-in-time compiler used to convert missile code into the output code. Output code means .exe file. Understand? Yes. Understand? Yes.
Yes.
That's right. So first we have to understand the compiling structure. Then we have to understand the uh, CLR architecture. This is also part of the compilation only. So next. Yesterday I showed older version of the .NET. Now I'll show you new version of the .NET. Actually, I installed 10 days back. So preview of 2012 .NET. Okay, I'll show you that also. What is the difference you have to understand? Observe here. Visual Studio 2012. Create new project. Okay. Check it here. So here I have different applications. Okay. Web applications, console applications. Web applications and console applications. If you want to use the Windows also, we can. This is Visual Studio. Sorry, Visual Basic. Okay. Now here we have ASP.NET web application with the C#.NET. Okay. Console application with the C#.NET. Just to select this. Just to select this. Okay. And click on next. So next, click on next. So actually, this is a new version, advanced version, still under testing only. Okay. So .NET 6.0 framework. Create the project. Now program.cs. See, observe here. Just I am writing only the console at right line here. Observe here also. File, new project. File, new project. New project. Visual C# console application. Now observe here the difference. I am writing this one statement here. Console at right line. Come to C#. And here we have to mention the console date here. Now build solution. This is how to run the C# program here. Now Observe here. Build solution. Now debug. Start debugging. Hello. Okay. Right. So actually, remember this. So when we use the Windows, Visual Studio Advanced versions, it will take more time actually. It will take more time to execute because it required almost 15 to 20 GB from your C folder. So older languages are taking less memory and also execution is faster actually. Right now, this is how to compile here and compile here. Actually, so still this is a new version actually testing version. Okay, it's a testing version. So right. Okay. Next, data types used in the document. Okay, next topic is data types used in the document. Data types. So observe here. Data type. So we have basically two types of data types. We have other data types also, but basically we have two types. One is value data types. Value data types. Reference data. Value data types and reference data types. First one is value data. These are also called primary data types. Are primitive data types. Also called primary data types are primitive data types. These are having fixed memory. Fixed memory. So that is stack memory. STS is stack memory. Now see example. Integral data types. Floating point data types. Character data types. So these all are the primitive data types. Primitive data types. First, integral data types. Here we have different data types. First one is byte. 8 bits of memory. 8 bits of memory. Actually, byte we won't use in .NET. So even though it is a integral data, from start you have to start in 16 bytes, 16 bits. 2 bytes. Integer. We can call it signed int. Okay. So 32 bit. So this is the default type in .NET. We are using majorly integer only. If required, you can use the so short and long also. 4 bytes of memory. Fourth one is long int. 64 bits. 64 bits. Or 8 bytes. So these are the integral data types. Okay. That means only digit value. These are having the only digit value. Doesn't tell us any floating point value. Okay. Now, floating point value. Float 4 bytes of memory. Double 8 bytes of memory. Actually, after the point only takes 6 digits. Here, after the point, it takes more than 6 digits. That's the advantage double. So here, default type is int. Here, default type is okay. Double. Next. Character data type. Only one data type here we have, that is char. Having only 2 bytes of memory, at a time a char data can hold only one character. So this is about character data. Okay. Observe here. So integral, floating point. Okay. Floating point, character types. Next. So reference data type. 1 minute. Reference data is also called derived data are non-primitive. These are having temporary memory. So heap memory, that is heap memory. Examples: array, string, class. These are the reference data. Okay. So value data types are the predefined data types. Okay, already defined one. Okay. Reference data types are the derived from the, these are also predefined, but derived from the okay primary types. So other than this we have okay delegates, generics are the user defined data types. Okay, delegate, generics are the user defined data types. Okay, so these are the data types we have overall. Right now, how to declare the data? Observe here. Int a comma b comma c. A is equal to something, b is equal to something, c is equal to a plus. Now see, I want to print the output, just sum. So we want to print, okay, the value beside sum. I have to concat. Plus is the concatenation symbol. I have to give plus. Okay, now see, build solution, debug. Okay, sum is equal to 120. This is how to declare the data types. For example, if I want to declare more than one data type, sorry, I want to print more than one output at a time. D, E, F. Okay, now see, D is equal to A minus B. D is equal to A minus B. E is equal to A asterisk B. F is equal to A divided by B. Okay. Now, sum plus. For the space, I am giving double quote. So I'm adding that. That means I'm concatenating the space. Next to subtraction plus D plus space multiplication plus E plus E plus double quotes division. Yes. Now see, build solution, then D. So some subtraction, multiplication, division. Because of integer, okay. So less than one, if you have, that will become 0, right? So I want to print line by line. I want to print line by line. Simply where we are adding the space, in that we can give the slash n. Slash n will give the new line. Defaultly right line is a, okay, line by line. So same right line, if I write more than one statement, if I want to do next line, so we have to use the, okay, we have to use the slash n. Slash n means new line. Okay, now see, build solution, then this. Understand? Yes. Understand?
Yes.
So, anybody
Yes.
has doubt?
No.
Okay. So this is about to integer type of, okay, data type declaration. Now if I use a float, so we won't generally we won't use the float, we use the double only. Double, okay. When I use the double, I can use the decimal values. Build solution. Okay, now